Hi AP Stats kids. Today we're going to focus on the first part of Unit 4. Now, there's a lot going on here, so I need some help from you. The first thing I need you to do is on this PDF, I want you to pause the video throughout when I'm talking about things, and I want you to actually try the practice problem. The next thing I need you to do is I need you to write down anything that you would like me to make a longer video on. For example, maybe it's the tree diagram or the Venn diagram, whatever that may be. I am willing to go through a longer one with you guys as a video as well. Lastly, what I'm going to do is I've made a lot of videos over probability already. I'll compile a list and I'll also publish that on Schoology as well as a playlist for you guys. All right, let's get going. Let's start with the basic probability. So basic probability, hopefully we all feel comfortable with the number of favorable outcomes, favorable events out of the total events. So for example, if you were rolling a number cube, 6 sides, that's the total number of events. You want to know what's the probability gets an odd number. 1, 3, or 5, that's 3 favorable outcomes out of 6 total, 0.5. Next, what I want to move on to is this keyword or. When you see the word or, okay, that's where you're going to use that addition rule, okay? So let's say I want to say what's the probability that it is a 2 or a 6, okay, when I'm rolling a number cube. I'm going to take the probability that it's a 2, so there's 1 2 out of 6 total, 1/6, plus the probability that it's a 6, I think I said. That's that one right there. 1 out of 6, that would give me 2/6. Now we see the subtraction right there. That's where we have to ask ourselves, can you get a 2 and a 6 at the same time? If you can, you need to subtract that event, right? If you can't, you don't worry about it, okay? So that's our addition rule, and that is on your formula sheet. And now this year, the year 2020, you do get to use, it's an open notes exam, right? So you're going to want to make sure you've compiled a list of everything you need. You only get a certain amount of time, so you can't be like, scurrying through your notebook. You have to make sure you have all your formulas and know how to use these. Okay, next I want to move on to the multiplication rule. This is when you have a sequence of events happening. That would be, what if I ask you what's the probability of getting a 2 and then a 6, okay? So that's where, those are right now our independent events. Really all you need to know is you need to know, hey, I'm gonna multiply these events together. So the probability of a 2 is 1 out of 6. Then you're gonna say times the probability of a 2 again, or a 6 is 1 out of 6. So I multiply those two events together. Now, the catch is if they are not independent, okay? So an example of this would be, imagine that you have a sock drawer, okay? All your socks are nicely matched up. You have 3 pairs of red socks, 3 pairs of white socks, and 4 pairs of black socks, okay? What's the probability I pull out a pair of red socks and then a pair of white socks, okay? So I said we had 3 pairs of red socks, so that would be 3 out of 10, right? Times, now, because you take those socks out and you don't put them back in, that's a conditional probability. So that, we assume that that event already happened right there, and you can see that on my cursor. So now I only have 9 total pairs of socks in my dresser, and I have 3 white socks left, so times 3 out of 9, okay? And again, I'm going to try to give you all these types of problems, but I just want to make sure that we have that down. Give me 1 second. My husband is browning beef, or yes, he's cooking beef. We're going to have shepherd's pie tonight. I need to quickly turn it down because I feel like it's really loud. I hope that's not making too much noise. Okay, all right, let's move on. Next, so we got the or, we have the and, okay? And now let's get on to really what some of this stuff is here and here. So make sure you understand how to get these answers. So here, let's talk about independence. So on here, I must have independence somewhere. Do I not? If I don't have independence, this is an issue, okay? Let's write down right here what independence is. Okay, so I have, if I want to prove that two things are independent, okay, so that's event A and event B are independent. I want to say the probability of A and B both happening have to be equal to the probability of A times the probability of B. So keep in mind, these are two separate problems. In class, I went like this, and I worked on just this problem over here. And then I worked on this problem. You take the probability of just A times the probability of just B. Now, there is another way to do that as well. You can also say the probability of B given A has to be equal to the probability of B. So that leads us to this conditional probability. So I want to talk about that with you real quick. Let me go back to my, and that's right here, conditional probability. Okay, so the probability of A given B. The way I taught this is I said, hey, just really think about this as your fraction bar, right? So right here and right here. And think about this as saying, hey, in my denominator, I want B. So either it's a probability or it's just all the outcomes in B, okay? And I'll give you an example here in a second. In the numerator, then it's always both. So when you're finding out the conditional probability of A given B, whatever's in this position, that goes in the denominator. And then in the numerator, it's always both. So I think I give you an example here, but if I don't, I could say, hey, what's the probability if I look at this two-way table here, and we have 1,000 kids' names in a hat, right? And they're either female or male and participate in after-school programs, or they don't, okay? What's the probability, given I pull out a female, that the person is in after-school activities? So now, as the denominator, I would want all the females down here, okay? In the numerator, then, I want females and, right, in that after-school activity. So that's right here, 232. So the way I taught my students was make sure you always circle the given when you're dealing with a two-way table, like we have right here. All right, again, just want to give you a friendly reminder. It's really, really important as you're going through this, you're pausing. I'm going to post this PDF, but you're pausing and you're writing down any questions like, wait, what is she talking about? Because like I said, there's so much going on here. I really want to make sure that you can go through this if you need to. Okay, I want to go back to the idea of independence, okay, and the Venn diagram. So right here we have a Venn diagram, okay? And how I taught you to draw the Venn diagram is, an example here would be, hey, the probability of A is 0.7. So we know that is all here. This whole thing adds up to 0.7. The probability of B is 0.5. So this circle adds up to 0.5. And the probability of A and B is 0.3. So that's right here, okay? Now, you need to make sure that you understand how to set that Venn diagram up. So the way I taught it was I said, always start in the middle. So we know this 0.3 represents A and B. Then what we talk about is we say, hey, this whole circle here, right? That has to equal 0.7, but 0.3 is already part of it. So that means, well, 0.7 minus 0.3 gives us 0.4. So that's this part of the circle right here. Okay, then with the probability of B, we know this is 0.3, and this whole circle has to be 0.5, which leaves us with this part right over here, that's 0.2. Now I said, are the events independent, okay? Do you know how to check this? So the probability of A and B together, they told us is 0.3, okay? If they're independent then, right? We know the probability of A and B is 0.3. If they're independent, all of probability A times all of probability B has to equal 0.3. So let's go back. All of A is 0.7. All of B is 0.5, which gives us 0.35, which means A and B are not independent. It's as easy as that. Okay, let's talk a little bit right now about what does it mean to be mutually exclusive. To be mutually exclusive means it cannot happen at the same time. So how do I prove this? So if you're asked to prove independence, you have to show me the math like this. You may be asked to prove if something is mutually exclusive. If something's mutually exclusive, all you have to do is show that it's not equal to 0 or it is equal to 0. So if I'm asking if being a female and participating in after school events is mutually exclusive, don't give me some long answer. All you have to do is say no, because the probability of being female and participating in after school sports at the same time is 232 out of, that should be 1,000, not 100. And that's not 0. That's all you have to say. Mutually exclusive, two things can't happen at the same time. All right, let's keep cruising through here. Simulation, let's get back to that in a second here. The probability, okay, one thing that I have noticed on the AP exam, sometimes what they'll do is they will say two events are independent. The probability of A is 0.7. The probability of B is 0.5. What's the probability of A and B? Just knowing that center part. Or they might give a conditional probability off of that. And you need to know then what that center is. If you're a little confused on what I just said now, again, write it down. Just talk about how I said this little piece here. What is the probability of A and B in the Venn diagram if it's not given? If they're independent, talk something about that to me so I know what you're talking about. The tree diagram. The tree diagram is a really big thing, you guys. I do want you to pause through this and I want you to try this problem, okay? I have the key pretty much here. And make sure you understand how we got this information based off the example before, okay? So what you're gonna do right now is you're gonna maybe, let's see if I can do this. I'm actually gonna go like this, okay? I'm gonna send it to a new page. Perfect. Okay, the chances it will rain on prom day is 25%. Whenever Sammy needs to be somewhere, she tends to run late. If it's raining, she's late 20% of the time. If it's not raining, she's late 10% of the time. Could you set up a Venn diagram with this situation? Now, when are you going to use a Venn diagram? A Venn diagram is often used when there's several events going on here. So it's not just like, what's the probability of we'll win the first baseball game and then the second baseball game? Or it's the probability of flipping a head and then flipping a tail. It's not that simple. There's a lot going on here. Prom day is happening, okay? Sammy needs to be there. She either runs late or she doesn't. And it either is raining or it doesn't. So there's a couple things going on. So hopefully that can help you. And I'll make sure to post one where you need to do a tree diagram. We're spending all of this week on probability. Okay, try that right now. And then go back and check. Can you, whoopsie, not Facebook, sorry. We want our PDF here, forgive me. Okay, so we have to decide what has to come first. Is Sammy gonna be late or not? Or is it gonna rain or not? Well, it's gotta rain or not first before she can even be late, because she's gonna be even later if it does rain, okay? So it either rains or it doesn't. Now, how do we get that 0.75? What you need to remember is that these two branches together always have to equal 1. So she's late 25% of the time, which means, rains 25% of the time, and then doesn't rain 75% of the time. Next, she tends to run late. If it's raining, she's late 20% of the time. So we go to the blue one here. If it rains, she's late 20% of the time, so 0.2. That means she's not late 0.8% or 80% of the time, forgive me. 0.8 plus 0.2 equals 1. Then it says if it's not raining, she's late 10% of the time. So you go to the blue, it doesn't rain, 0.1, 0.9 has to add up to 1. Now, the biggest thing people forget to do is you need to multiply these branches. 0.25 times 0.2, that gives you rain and late. 0.25 times 0.8, rain and not late. 0.75 times 0.1, no rain, late. 0.7 times 0.9, no rain and late. And then once you multiply all those numbers right over here on your worksheet or on your notes, those are the only numbers you'll use when you're answering the question. So the probability of rain and being late, 0.05, rain and late, right here. The probability of being late, well, I can be late right here, or I can be late right here. So I need to add up that 0.05 plus 0.7 times 0.1. Add up those right there together. You must make sure you know how to do this. So please be practicing it on your own. And I can do a whole video on this if you need, okay? Finally, the last one, the probability of rain given she's late. So you need to think about, okay, in the denominator, where is she late? She's late right here, right? So whatever you get for an answer there. Or she's late right here. Whatever you get for an answer right there. That goes in the denominator. In the numerator, then, it's raining and late. Raining and late is right here. We spent a lot of time on my class on the tree diagrams. It's so important, okay? Make sure you understand that. And if you have any questions, please, please, please don't hesitate to ask. Okay, I think we have gone through almost everything on here. I don't think I talked about this right here, but make sure you understand that. You can read that on your own. Two things to talk about. Whenever it says at least one, always do 1 minus the probability of none. We've talked a lot about that. And the last thing that is in this unit is that simulation. And knowing how to find probabilities based off that simulation. And I think what I'm going to do is I'll quick talk about it. And I definitely want to make sure I pick a free response problem for you guys on that so you understand how to do it, as well as maybe even make a separate video for you or look and see if I have a separate video to post for you as well. So I'll do that tonight for sure. Okay, so when you're representing a simulation, there's a couple of them that we did. One could be, for example, I think I did one where there was a school assembly, right? And there were 500 kids and 50 teachers, okay? And 3 teachers' names were pulled out to win this raffle, and kids cried foul because they're like, what? Based on probabilities, that shouldn't happen. So in a simulation to figure out probabilities, the first thing you need to do is you need to be able to represent the sample space using numbers. So in this case, if you said, okay, hey, I have 400 students, I think I said, and 50 adults, you would say 001 to 400, that represents students. 401 to 450, that represents teachers, okay? Then what you're going to do is you're going to simulate a trial. So you're going to generate random numbers. Most likely on the AP test, if they have you do this, they're going to have you use a table. So you would say, I'm going to go across the table by 3 digits, right? Why 3? 001 to 450 were the numbers we used. We're going to go across. We're going to go by 3 digits, okay? And we're going to say, hey, if the number's between 001 to 450, that's a raffle ticket. If it's 401 to 450, that represents a teacher. If it's 001 to 400, that represents a student, okay? Hopefully this is ringing a bell. Again, I can do a separate video. We go across, we throw out repeats, we throw out any numbers that aren't in our range, and we do this for 3 times for that trial because we're pulling out 3 tickets. We record, yes, it's all teachers, or no, it's not. We do this for many, many trials and continue and say yes or no because we're simulating 3 tickets each time, right? At the end, let's say we do it for 20 times. We count up how many yeses we have, meaning there was 3 teachers called out of the total trials, and that is our probability based off a simulation that 3 teachers would be called in the raffle. Usually then it will go on to say, is that a likely event, so on and so forth. And if it's under about 5%, then you say it is not likely, okay, to happen. If it's over 5%, you say it's not unlikely. All right, I believe this is everything I have on this page. If something comes up, please let me know. You guys keep staying strong, keep smiling. I miss you guys a ton. And yeah, we'll just continue to get through this together. You guys have been amazing, and have a great night.